teaching through book 6, where we do a lot of skip counting again, counting in groups. And in that way, we have prepared children for multiplicative thinking and giving a lot of exposure to ideas of 36 is so many 2s, so many 4s. But it is only in this book, book 6, where we introduce the formal multiplication and the symbol for multiplication. And we do that by showing a tray with mugs on. We've got 3 rows of 4 mugs each, and we can write that as 3 times 4. So the symbol is introduced as social knowledge. They must simply get to know and remember this, but the idea, the concept, is already familiar to them. So we can look at it from the other side. We can also say 4 times 3. That also gives us 12. And we follow that up with a different view of multiplication, that of repeated addition. So 3 plus 3 plus 3 plus 3 bananas also gives us 12 bananas, or 4 plus 4 plus 4. So all the different ways of multiplication are used in the introduction of the symbol. And there's a lot of follow-up by that, and then we can start asking formal tables. When we do tables, we pay a lot of attention to, or we try to do that, to patterns. Like when you double, 4 is 2 times 2, and when I double 4, it will be 2 times 4. And if I take it 3 times, I will have 2 times 6. So 3 times 2 is 6. So we also ask parents and teachers to draw the children's attention to the patterns and the relationships between the different multiplication facts, instead of simply memorizing the tables by heart. The other important feature of book 6 is where we continue with the number sequences, and we try to represent them on the next page on a grid, where we call them block towers. Now, the idea of block towers were introduced in book 5, in the previous book, where we told them what is meant by a block tower and where they had to color in the little blocks like that. But here we do it in a different way. We also expose them to the visual idea of growing patterns. So the first one, we've got 1, 2, 4, 8, 16, 32, 64. So that is produced by doubling, while the next one is simply the multiples of 3. So in this case, the growth is very fast. Oh, sorry, I have the wrong one. So this goes like that, very rapid growth or exponential growth, because this is the exponential function. And we contrast that with a linear function where we've got the multiples of 3, 6, 9, 12, 15, etc. So this idea, the idea of growth and different rates of growth, rates of change, is the basis of calculus, which children might encounter later when they start doing formal algebra.